Hello viewers, welcome to our series on linear programming. In our previous two lessons, we talked about what linear programming is, how to formulate linear programming problem and also how to solve it graphically using corner point method. Let us take a quick recap and then proceed ahead with something new for you. The problem of linear programming and therefore, the process of linear programming focuses on finding optimal solution, maximum or minimum of a given linear function which is referred to as the objective function under a certain set of constraints which are again linear inequalities. So, linear programming is defined as the process of taking various linear inequalities relating to some situation and finding the best value obtainable under those conditions. We saw and discussed that there are lots of applications of linear programming. Most common of these are found when we want to minimize cost while meeting certain product specifications, maximization of profit with optimal production processes or products, minimize cost in transportation routes and then also to determine the best schedules for production and sales. Also the cheapest combination of foods that will satisfy all nutritional requirements. The problems that we discussed in the previous lessons covered most of these situations except for the one where we have to minimize cost in transportation routes. How and what that is what we are going to discuss today. In situations where we want to transport goods from 1 or 2 points to 2 or 3 points, how do I decide how much should go from and where to, so that the cost of transportation is minimum? That is what is referred to as transportation problem, which we will discuss today and solve using corner point method. Again, get your NCERT books open. We are referring to a problem from the NCERT exercise and these are long statements. So, it will help to read the statement along with me. Here is the problem that we are going to discuss. The problem is on page 526, question number 6. It says that two godowns A and B have grain capacity of 100 quintals and 50 quintals respectively. They supply to 3 ration shops D, E and F whose requirements are 60, 50 and 40 quintals respectively. The cost of transportation per quintal from the godowns to the shops are given in the following table. So, if you read this table, it gives you complete information that from A to D per quintal transportation cost is 6 rupees, from A to E 3 rupees, from A to F rupees 2 and 50 paisa. Similarly, you can read for what happens if I transport 1 quintal from point B to point D or to E and then to F. Now, the problem is to find how should we transport these supplies in order that the transportation cost is minimum, and also to find what is the minimum cost. So, if you start looking at a problem like this, then what we have to understand is as to what would be our variable, what we refer to as the decision variables. What are we going to assume as our x and y? So, why do not we start by thinking that from the point A, suppose we supply x and y quintals of grain to the shops D and E respectively, and therefore, F shop would get what is left with A, that is 100 minus x minus y quintals. Similarly, the requirement of D shop was since 60 quintals and it has already received X quintals from A. Therefore, the remaining, that is 60 minus X quintals, must be transported from godown B. And now, if you follow that logic, then 50 minus Y quintals must come from B to E, and the remaining, that is the requirement of shop F, will be met by the remaining quintals that are left with the godown B, which amounts to 40 minus 100 minus X minus Y, the requirement of shop F, or X plus Y minus 60. If this information sounded too complicated to follow, let us try to represent this information and our assumption in a diagram. That will make things very easy to follow. Start with assuming that we have as given two godowns A and B marked as points or circles as in this figure. So, godown A has 100 quintals goods and B has 50 quintals. There are three shops D, E and F with their requirement listed, and we need to transport from A and B to these three shops. Started with the assumption that let X quintals be transported from godown A to shop D, Y from A to E, and therefore, from A to F you will get 100 minus what has gone to D and E. So, therefore, 100 minus X minus Y quintals will be transported from A to F. Now, I am sure you can figure out how much will get transported from B to D. D has already got X quintals from A. So, from B it should get 60 minus X quintals, from B to E 50 minus Y quintals, and then from B to F the remaining, that is the requirement of 40 quintals of F has to be satisfied. It is already got 100 minus X minus Y quintals. So, you may say 40 minus 100 minus X minus Y amounts to same as X plus Y minus 60. And of course, this quantity should be same as what is left with B. Check, is that so? Another interesting and important aspect of this problem is the cost which we want to minimize. So, we are given that 1 quintal from point A to point D cost us rupees 6 in terms of transportation, and for 1 quintal to be transported from A to E it costs 3 rupees, from A to F it costs you 2 rupees 50 paisa, from B to D 4 rupees per quintal, B to E 2 rupees per quintal, B to F it costs rupees 3 per quintal. So, your entire statement that was given to you has been translated and represented in this diagram. Now, the other interesting aspect of this problem is what is our objective function and what are the constraints. Now, if you think about it, objective function is to minimize the cost. So, I must be able to find the total cost of transportation from A to these three shops plus the cost of transportation from B to these three shops. Alright, so I can always do that. But what about the constraints? Under what constraints are we working? Something very obvious. The amount transported from godowns to the shops, they all have to be positive quantities, and that is where we start building up the constraints. And therefore, in this situation, we start with of course the assumption that X and Y are both positive. 100 minus X minus Y also must be greater than or equal to 0. Therefore, you get three conditions from here: X is greater than and equal to 0, Y greater than or equal to 0, X plus Y less than or equal to 100. Similarly, 60 minus x, 50 minus y and x plus y minus 60 must be all greater than or equal to 0. Rewriting, I get 3 more inequalities. So, these are going to be 6 constraints under which we want to now minimize the total transportation cost. And what is the total transportation cost? Just keep this figure in front of you and now calculate the objective function, which is going to be nothing but 6 times x plus 3 times y plus the cost from A to F. So, 2 rupees 50 paisa per quintal. For 100 minus x minus y quintals, it will be 2.50 times 100 minus x minus y. To this, we will add 4 times 60 minus x plus 2 times 50 minus y plus 3 times x plus y minus 60. Now, patiently and very carefully simplify this expression and you will find yourself with a linear expression. In this case, it amounts to 2.5 times x plus 1.5 times y plus 410. And therefore, we are ready for formulating, listing down the entire problem as we want to minimize z, which is the transport cost. In this case, 2.5 times x plus 1.5 times y plus 410, subject to the 6 constraints that we figured out of which of course 2 are the non-negative restrictions. And now to solve. So, solve graphically would mean we will plot these linear inequalities, decide their solution region, consider the common solution region which is referred to as the feasible region. In this case, I have mainly 4 linear inequalities to understand. In this case, x plus y less than equal to 100 and the other line as you plot would also be parallel to x plus y, and one of them is a vertical line, the other is a horizontal line. When you take the testing point maybe for all of them as the origin, you will be able to locate the feasible region, which in this case turns out to be a nicely bounded region. I am sure you will react and say, well, that is definitely nothing but a trapezium. In this case, yes, that is exactly what you get. The corner point method requires you to find the corner points. They are very easy to read corner points in this case if you are working with graph paper, but do not take a chance if you are not sure of them. Solve the 2 equations which are leading to that point of intersection and then decide on corner points. Corner point method requires you to find the value of the objective function at these corner points. Our objective function was 2.5 times x plus 1.5 times y plus 410. Here I have 4 corner points A, B, C and D with their coordinates listed as you can see. Calculate z at all of these 4 points. Do you see a minimum cost coming up somewhere? Yes, I think so. That is very, very obvious. So, we are looking at a minimum transportation cost of 510 rupees at the point D, which has coordinates 10, 50. So, do you think our problem is solved? The requirement of the problem was decide how should we transport. So, the conclusion must be written as the transportation schedule that needs to be formulated. How much should go from A? X is 10 in this case. So, that is how we start listing out. From A to D, we must transport 10 quintals, the value of x that we have. Y was the assumption for transportation of y quintals from A to E. So, 50 quintals goes from A to E. Once I have the values of x and y, I can find all the amounts that we had assumed to be transported, and therefore, your conclusion has to be written in very detailed form. You may also represent this as a table, but if you write it in words as a paragraph, that also is perfectly fine. So, our solution would look like the amount of grain transported from A to D, E and F is 10 quintals, 50 quintals and 40 quintals respectively. And from B to D, E and F, using the value of x as 10, y as 50, it amounts to 50 quintals, 0 quintals and 0 quintals respectively. And the minimum cost is rupees 510. So, that is how one would be able to solve the transportation problem. A little more work, a little more planning to be done, how you interpret the problem, but I hope you have followed it and you are ready to try one more or two more of the same kind from your textbook. In our next lesson, we will take some special cases. Hang on till then and I will see you there. All the best till then.